Hi, this is Shakil Ahmed. In this video, we will discuss how a negative binomial regression model is used. As we previously discussed that the Poisson regression model assumes that we have equal mean and variance, but in most of the cases, we come up with over dispersion, and then we need to go for negative binomial distribution, negative binomial regression. So negative binomial regression basically adjust for over dispersion by including an over dispersion parameter that is called theta apart from the mean. So it accounts for the dispersion parameter. But in Poisson regression, we have only one parameter that is mu, that is the rate, and that depends. We link the mean with the uh, covariates. But here we account for the dispersion as well. So you need to install the package mass package, and the GLM-NB is used for negative binomial. This is also a family of own regression models, and we can get from a mass package. And this example, we again using the chronic counts as we that is obtained from National Health and Nutrition and Examination Survey, as we already used in our previous example. And the sex and ethnicity of the individuals are taken as the predictors, and we include the data frame on 9,756 patients from the 2017 and 18 cycle of National Health and Nutrition and Examination Survey. So we can just we can call this library and run a negative binomial model. And we again check for the deviance. You can just again see both the sex and ethnicity are not significant, as there is not much difference in the result we got in Poisson and this result, as there were no issue of over dispersion. But we are just checking how negative binomial model works. So this is again saying that the sex and ethnicity are not uh, the significant predictors of the chronic conditions, chronic counts. So we have again the null deviance and residual deviance. You can see that the null deviance and residual deviance are almost same. It means the models is not improved at all by including these predictors in our model. The deviance we got for null model when we use no variable, and the deviance we got when we included age and sex and ethnicity in our model uh, are almost equal, but with reduced degree of freedom as we are using two predictors. So this is there are two parameters, that is theta and the standard error. We have basically mean and the dispersion parameter, that is theta, and we have also got the value of 2 log likelihood, and that can be used for likelihood ratio test. We again apply a likelihood ratio test, and this is again insignificant, and these variables are not improving the model. And we are again check for the influential influence plot to see whether the variables now we have only a few data points. Basically we are just categorizing data on the basis of three categories in ethnicity group, ethnic group, and two categories in uh, sex group. So we have a limited number of categories. So we have a limited number of data points, and you can again see what how the data points are influencing the model using your head value, and how which uh, data points are outliers by checking the studentized residual. These are the outliers, and this value is basically a very influential value, as this is outlier and this is influencing your model, as the head value is also larger for this, and the studentized residual is also larger, and the color is dark. It means the Cook's d value is also large for this data point. So this data point is very influential to your model. Excluding this uh, data point from model will influence your the results of your model. So this is just an alternate of Poisson regression when you have a problem of over dispersion. The other issue is when we have excess zeros, we have a large number of zeros, then we need to go for zero inflated models. In next tutorial, we will discuss zero inflated models. So thank you for watching this tutorial, and don't forget to subscribe to my channel. Thank you.